A single planet among trillions spins silently in the vast cold theatre of the void. It is a world born of cosmic dust and stellar fire, a sphere of liquid water of silicate continents sculpted by eons of geological time and a thin nitrogen-rich atmosphere. For 4 billion years it has been an unremarkable stage for a slow, meandering play of chemistry and geology, a quiet backdrop in a galaxy of countless similar stages. But something is profoundly different here. On its sunlit surfaces and in its dark abyssal depths, a pattern has emerged, a complex information, hoarding, self-replicating chemical reaction we have named life. This delicate phenomenon, this brief flicker of organized complexity against the universal tide of entropy, has now, after a long and brutal evolutionary climb, produced a species capable of crafting instruments of exquisite sensitivity, of turning them towards the heavens, and of asking the most fundamental question it can conceive. The question is simple, born of an innate and deeply felt solitude. Are we alone? The universe in its vast, cold and ancient indifference has so far offered a single, unambiguous and deeply unsettling answer. The answer is silence. A cosmic quiet, so profound, so absolute, that it feels less like an absence of sound and more like the active presence of a vast, final stillness. This is the great, terrifying context of our technological existence. We find ourselves a solitary voice in what should be a crowded and noisy cosmic cathedral. The statistical arguments for company are not just strong, they are overwhelming, almost mathematically coercive. Our home galaxy, the Milky Way, is a sprawling, luminous city of between 200 and 400 billion stars. Our spaceborne telescopes, tireless robotic eyes staring into the dark, have revealed a staggering truth. Planets are not a rare cosmic accident. They are the common, inevitable children of stellar birth. They are more numerous than the stars themselves. From this galactic census, we can infer the existence of billions of worlds that are rocky, roughly the size of our own Earth, and orbiting within the temperate, life-friendly, habitable zones of their parent suns. The raw materials for life as we know it, water, carbon, the complex organic molecules forged in the hearts of dying stars and scattered through interstellar clouds, are not rare commodities. They are ubiquitous, the common dust and vapor of the cosmos. The timeline is almost incomprehensibly long, the real estate nearly infinite, the chemical ingredients utterly commonplace. By all rights, the galaxy should be a teeming, noisy metropolis of life, a brilliant, interconnected network of civilizations broadcasting their art, their science, and their very existence across the interstellar night. Yet the sky is dark. The radio spectrum is quiet. The great engineering projects of elder races are nowhere to be seen. The gardeners have not tended the cosmic garden. This gaping, silent chasm between a universe that should be loud and a universe that is quiet is the core of the Fermi Paradox. It is the sound of one hand clapping the answer to a question that no one is asking. On a quiet afternoon in 1950 at the Los Alamos National Laboratory, the brilliant physicist Enrico Fermi, while discussing the possibility of alien life over lunch, is said to have cut through the speculative haze with a simple, devastatingly logical question. But where is everybody? That question has echoed through the decades, its power and its poignancy growing with every new exoplanet we discover, and with every year that our own systematic search for signals comes up empty. The paradox is not a mere intellectual curiosity. It is a profound clue, a piece of negative evidence of immense significance. It strongly suggests that something is fundamentally wrong with our optimistic assumptions about the universe and the potential for life within it. It implies the existence of a barrier, a wall of near impossibility that stands somewhere on the long, arduous and multi-billion-year road that leads from a sterile planet to a galaxy-spanning civilization. This hypothetical barrier is known by a simple, chilling name: the Great Filter. It is a cosmic guillotine, a single, impossibly difficult evolutionary or technological test that has, it seems, severed the ambitions and the very existence of every species that has ever attempted the journey before us. The Great Filter is not a physical wall in space, not a tangible object that can be seen or touched. It is a probabilistic one, a bottleneck of such extreme difficulty that it chokes off the emergence of widespread visible intelligence. It is a step or a series of steps in the chain of cosmic evolution that is so fantastically unlikely that it has effectively prevented the galaxy from being colonized, from being filled with the light and sound of mind. The profound silence of the universe is the primary and so far only piece of evidence that such a filter exists. The galaxy in this interpretation is not an empty stage waiting for the first actors to arrive. It is a graveyard of failed attempts, a silent museum of species that reached the filter, faced the test, and could not pass. We, in our noisy, technologically adolescent and perhaps fatally naive civilization, are now approaching this same wall. The profound and existentially unsettling question is not whether the filter exists, the silence screams that it does, but where it is located in relation to us. Is the Great Filter in our deep primordial past a hurdle of cosmic improbability that we have by some staggering 1 in a trillion miracle already overcome? Or is it, in our near and rapidly approaching future, a doomsday deadline that is drawing closer with every new technology? We invent a final exam for which we have not even begun to study. Our entire existence, the collective future of every living thing on this planet, hinges on the answer to this one terrifying question. If the Great Filter is in our past, then we are a species of breathtaking, almost unimaginable rarity. We are the first, and quite possibly the only form of life in our entire galaxy to have survived the gauntlet. The profound silence of the universe in this case is not a threat but a confirmation of our own miraculous and lonely status. The cosmos is an empty kingdom of vast silent inheritance, and we are its sole bewildered heirs. This is a hopeful, if profoundly solitary vision of our future. It means the path ahead, while not without its own challenges, is fundamentally clear of the one great barrier that has stopped everyone else. The hardest part is over. Our destiny and our responsibility is to carry the fragile, precious flame of consciousness out into the great empty night to become the gardeners of our own silent galaxy. But this conclusion requires a level of cosmic arrogance that sits uncomfortably with the lessons of our own scientific history. It requires us to believe that we are in some fundamental way special. It demands that we look back with an unblinking eye at our own bloody, contingent and accidental evolutionary history and find a step so difficult, so monumentally improbable, that it could plausibly be the single great barrier to the emergence of intelligent life in the entire cosmos. If, on the other hand, the Great Filter lies in our future, then the silence of the universe is not an invitation. It is a dire and urgent warning. It is a cosmic tombstone, a vast galactic epitaph for the countless civilizations that reached our current level of technological prowess and then invariably and without exception perished. The silence in this interpretation is the sound of universal, self-inflicted failure. We are not the first. We are just the next in a long, tragic line to face the test. The very technologies that we celebrate as the hallmarks of our success, our global energy systems, our mastery of the atom, our creation of artificial intelligence, may not be the tools for our salvation, but the very instruments of our inevitable self-destruction. In this profoundly chilling scenario, we are not a miracle. We are a species on death row, blissfully unaware of the executioner's timetable, mistaking the silence of the graveyard for the peace of an empty field. The Fermi Paradox is not a puzzle to be solved. It is a prophecy to be heeded. The quiet of the stars is the quiet of a tomb, and we are walking towards an open grave following the faint, ghostly footprints of 1 billion failed, forgotten civilizations. The search for the Great Filter is therefore the most important detective story in human history. We are sifting through the evidence of our own distant past and the probabilities of our own near future, looking for the murder weapon. The victim is the bright, vibrant, populated cosmos that should exist but does not. The suspect list is long and terrifying. It spans the entire 4.5 billion year history of our planet, from the first tentative spark of life in a primordial ocean to the final godlike act of re-engineering the galaxy. The filter could be a single catastrophic and improbable event, or it could be a long series of smaller cumulative hurdles, each one a roll of the cosmic dice. It could be a fundamental law of nature we have not yet discovered, or it could be an inherent self-limiting feature of intelligence and social organization itself. The only thing we know for sure is that the evidence of its terrifying effectiveness is all around us. It is written in the silent, untamed light of 1 billion empty stars. The blade of the cosmic guillotine has been falling for eons, its rhythm, the slow, patient pulse of galactic time. We are now in our brief, fleeting moment of existence, placing our own necks upon the block, hoping against all rational hope that the blade has already fallen somewhere far behind us on the long road that brought us here. The journey from a sterile molten rock to a planet-spanning technological species is a long and almost unbelievably perilous one. It is a tightrope walk across a 4 billion year chasm of non-existence with 1,000 different ways to fall. The Great Filter could be any one of the crucial, difficult steps along this path. Let us begin at the beginning, at the moment of Genesis, the origin of life itself. For the first few 100 million years of its existence, our planet was a chemical laboratory of unimaginable scale, a chaotic, violent crucible of water, rock, and simple organic molecules, all stewing under the steady, relentless bombardment of ultraviolet radiation from a young and angry sun. Somewhere in this primordial soup, on the shores of a volcanic island, in the superheated water of a deep-sea hydrothermal vent, or perhaps in the frozen heart of a comet that crashed to Earth, a remarkable and perhaps unique event occurred. A random collection of non-living molecules, through a long and statistically improbable series of chance encounters, organized themselves into a structure that could do something unprecedented, something that violated the simple downward slide of entropy. It could make a reasonably accurate copy of itself. This is abiogenesis, the spark of life, the ghost in the machine of planetary chemistry. It is the transition from the predictable, deterministic, and ultimately dead world of geology and chemistry to the open-ended, unpredictable, and creative world of biology and evolution. This is the first and, for many, the most plausible of the great and terrible candidate filters. We still do not know with any degree of certainty how life began. We have compelling theories, the RNA world hypothesis, which posits an early biology based on a simpler, more versatile genetic molecule, the metabolism first model, which suggests that self-sustaining chemical cycles preceded the development of genetic replication, the panspermia concept, which outsources the problem by suggesting that life arrived here from somewhere else. But despite decades of dedicated research, we have not yet been able to create life from scratch in a laboratory to coax a living, replicating entity from a sterile mixture of non-living chemicals. This persistent failure of our own increasingly sophisticated science is a profound and humbling clue. It suggests that the process is not a simple or a common one. The specific sequence of chemical reactions required to form a stable, self-replicating molecule complete with a primitive metabolism and a protective boundary might be so complex, so fantastically improbable, that it is a 1 in a trillion event, A planet could have all the right ingredients: liquid water, a steady supply of organic molecules, a persistent source of energy for billions of years, and this magical spark might simply never happen. Life, in this view, is not a natural and inevitable outcome of planetary chemistry. It is a cosmic fluke, a statistical miracle, a lucky roll of the universal dice that has happened only once in our entire galaxy. If this is true, if abiogenesis is indeed the great filter, then we have against all odds already passed the hardest test. The universe is not a graveyard of failed civilizations. It is a sterile womb, a vast fertile expanse, waiting for a seed that almost never arrives. We are that seed. All life on Earth, in its glorious, chaotic and interconnected diversity, is a direct descendant of that single, improbable chemical accident. The profound silence of the universe is the silence of a cosmos that is waiting to be born, waiting for us to bring it to life. In this profoundly optimistic scenario, we are not just another species, we are the beginning of the second act of the universe, the moment when matter awakens, looks around, and begins to understand itself. Our responsibility is almost too immense to contemplate. We are the custodians of the only known life in the entire Milky Way galaxy. The future of biology itself, not just of humanity, is in our hands. But what if this is too optimistic? What if life itself is common? What if that first tentative spark is an easy, almost inevitable chemical step on any vaguely Earth-like, watery, rocky world? The silence of the cosmos would then demand another filter, a second, even higher wall further down the long, winding road of evolution. For 2 billion years after that first spark, life on Earth remained stubbornly, almost perversely simple. The planet was inhabited exclusively by single-celled organisms, the prokaryotes, creatures like bacteria and archaea. They were incredibly successful. They filled every available ecological niche, from the deepest lightless ocean vents to the sunlit surfaces of the primordial seas. They even terraformed the entire planet, pumping a toxic, highly reactive and corrosive gas called oxygen into the atmosphere as a waste product of their metabolism. But they were small, they were simple, and they did not fundamentally change their basic bag-like cellular form for half the history of the planet. Then another event of staggering improbability occurred. 2 of these simple cells, through a chance encounter in the ancient ocean, merged. One cell, a primitive predator, engulfed the other, a smaller bacterium. But instead of digesting it, it formed a stable, symbiotic relationship. The smaller engulfed cell became a perpetual energy source, a biological battery we now call a mitochondrion, providing a vast surplus of power for its larger host. This was the birth of the eukaryotic cell, the complex, compartmentalized and powerful cell that is the basis for all animals, plants, fungi and protists. It was the birth of all visible macroscopic life. This eukaryotic transition is the second great candidate for the cosmic filter. It was, as far as we can tell from the genetic record, a singular event. It happened only once in the entire 4 billion year history of life on this planet. All eukaryotes, from a humble amoeba to a great blue whale, from a mushroom to a giant sequoia, are the direct descendants of that single, ancient and highly improbable merger. For 2 billion years, life on Earth was stuck in a prokaryotic rut. It took a chance encounter, a 1 in a billion biological accident, to unlock the door to greater complexity, to the world of tissues, organs, and integrated multicellular organisms. The evolution of a complex cell with its protected nucleus, its powerful mitochondria, and its intricate internal machinery of membranes and transport systems might be the true bottleneck in the story of life. A galaxy could be teeming with microbial slime, its billions of habitable planets covered in vast, colorful, single-celled mats, but it could be almost completely devoid of any life large enough to see with the naked eye. The silence of the universe in this case would be the silence of a galaxy of bacteria. We might be the only creatures in the Milky Way to have ever evolved a cell with a nucleus. If the eukaryotic cell is the great filter, then we are once again the beneficiaries of a cosmic miracle. The world of complex multicellular life might be a lonely, isolated island in a vast universal sea of microbial simplicity. The 2 billion-year wait for this event to occur on our own planet is a sobering and powerful piece of evidence. It suggests that the path to biological complexity is not a smooth, inevitable, upward-sloping ramp, but a treacherous, broken staircase with a single crucial step that is almost impossible to climb. The silence of the universe would be the silence of a world that has not yet mastered the profound and difficult art of cellular cooperation. We are the descendants of a primordial handshake, a single chance act of symbiosis that changed the destiny of a planet and perhaps of an entire galaxy. But the story does not end there. Even with the power of the complex cell, the path to technological intelligence is not a guaranteed one. For another 1.5 billion years, our planet was filled with a riotous diversity of complex multicellular life. It witnessed the Cambrian explosion, a frenzy of evolutionary innovation that produced the first animals with shells, legs, and eyes. It saw the rise of the fishes, the greening of the continents by the first plants, the age of the giant amphibians, and the long triumphant reign of the dinosaurs. The planet was a vibrant, dynamic, and ever-changing world of animals and plants, a complex ecosystem of predators and prey, of parasites and hosts. But it was a world without a mind capable of understanding it. The dinosaurs ruled the Earth for an astonishing 150 million years, a reign of unparalleled length and evolutionary success. Yet in all that vast expanse of time, they never built a fire, they never crafted a tool, they never developed a language, and they never looked up at the stars and asked the question, why? Intelligence, the kind of abstract tool-using, language-based self-aware consciousness that we human beings possess, is not an obvious or inevitable endpoint of the evolutionary process. It is a strange, new, and perhaps exceedingly rare adaptation. This is the third great candidate for a filter that lies in our deep evolutionary past, the emergence of human-level intelligence. The specific and highly contingent combination of factors that led to our own cognitive leap, the development of bipedalism which freed our hands, the evolution of the opposable thumb which allowed for fine manipulation, the rapid and energetically expensive expansion of our brain, particularly the prefrontal cortex, and the development of the anatomical and neurological structures necessary for complex symbolic language, may be another unique and unrepeatable accident of history. Evolution is not a ladder leading inexorably to us. It is a vast, chaotic, and branching bush. We are just one small, improbable twig on that bush. If the asteroid that wiped out the dinosaurs had been a few minutes earlier or later in its cosmic trajectory, if a certain group of arboreal primates had not been forced out of the trees and onto the open savanna by a changing climate, if a single critical genetic mutation in a brain development gene had not occurred, the story of this planet could have been very, very different. It could have remained a world of beautiful, complex, but ultimately non-cognitive life forever. If intelligence itself is the great filter, then the galaxy could be filled with living worlds, worlds of incredible biodiversity and breathtaking beauty, but they would all be silent to our radio telescopes. They would be cosmic gardens untouched and untroubled by the hand of a technological engineer. We would be the only species to have ever awakened from the long, sensuous dream of evolution. The profound silence of the universe would be the silence of a world of animals, a place of pure, unthinking and beautiful being. Our own consciousness, our strange and burdensome ability to reflect on our own existence would be the true miracle. We would be the universe's sole, lonely and perhaps tragically self-aware mind. These three great and improbable steps, the origin of life itself, the invention of the complex eukaryotic cell, and the evolution of human-level technological intelligence, are the leading candidates for a great filter that lies in our deep evolutionary past. If any one of them is the single great guillotine that has severed the hopes of a billion other worlds, then we have reason for a profound, if cautious, optimism. The silence of the universe is not a threat. It is an empty stage waiting for us to fill it. But this is a conclusion born of a deep and perhaps dangerously unwarranted optimism about our own future. It requires us to believe that the existential dangers we are currently creating for ourselves are trivial in comparison to the great cosmic hurdles of our distant evolutionary history. It is a comforting thought, a way of reassuring ourselves that the worst is behind us. But it may be a dangerously naive one. The silence could be telling a very different and much darker story. The hardest test might not be the one we have already passed. It might be the one we are about to face. The doomsday deadline may not be a distant historical memory, but a future that is rapidly and terrifyingly approaching. The moment a species develops technology, it begins a frantic, high-stakes race against time. It unlocks powers of a planetary scale, but it does not instantly or even quickly acquire the collective wisdom and foresight to manage those powers. This is the great central and perhaps fatal paradox of any young technological civilization. The tools of creation are with almost perfect symmetry also the tools of annihilation. The path to a stable, long-term and sustainable existence is a razor's edge, a narrow and treacherous ridge with the abyss of self-destruction yawning on either side. It is entirely plausible and perhaps even likely that the great filter lies here in this treacherous transition phase between a non-technological species and a mature planetary one. The galaxy could have been filled with countless civilizations that discovered science, built cities, developed global economies, and reached for the stars only to be destroyed by the complex, delayed, and unintended consequences of their own spectacular ingenuity. The silence of the universe would be the sound of a billion self-inflicted wounds, the quiet hum of a galaxy filled with ruins. We are now walking this same razor's edge. The next few centuries will be the test our own personal species-wide encounter with the cosmic guillotine. Consider the Industrial Revolution, the moment in our recent history when we began to burn the buried ghosts of ancient forests and plankton blooms to power our new miraculous machines. This was the birth of our modern world, the engine of our unprecedented progress, the foundation of our wealth, our health, our global transportation networks, and our interconnected information society. But it was also the beginning of a vast, uncontrolled and planetary-scale experiment with the chemistry of our own world's atmosphere. The fossil fuels that powered our progress, the coal, the oil, the natural gas released vast and ever-increasing quantities of carbon dioxide, a potent and long-lived greenhouse gas. For 2 centuries, we have been pumping this invisible, odorless waste product into our thin, fragile, and life-sustaining envelope of air, fundamentally altering the energy balance of our world. This is a classic textbook example of a great filter scenario, a phenomenon that has been called the fossil fuel trap. A young civilization discovers a cheap, abundant, and incredibly powerful source of energy. This energy allows for an explosive, exponential growth in its population, its economy, and its technological capabilities. But the waste product of this energy source, slowly, invisibly, and with a long delay, poisons the planet's climate system, creating a long-term existential threat that is incredibly difficult for a species that evolved for short-term, immediate thinking to recognize, to take seriously, and to collectively address. The consequences of this global success trap are now becoming terrifyingly clear, no longer a matter of future prediction, but of present lived reality. We are witnessing a rapid and accelerating warming of our planet, a fundamental destabilization of our ancient and familiar weather patterns, a relentless rise in our global sea levels, and a dangerous acidification of our oceans. We are, in effect, building our own slow-motion doomsday machine, a complex, interconnected, and self-reinforcing catastrophe of our own ingenious design. The planet Venus, our hellish sister world in the solar system, stands as a stark and permanent warning of what is possible. Venus may have once been a temperate, habitable world, perhaps with oceans of liquid water and a clement climate. But a runaway greenhouse effect, perhaps triggered by a period of massive volcanic eruptions, boiled its oceans away and turned its atmosphere into a thick, toxic, and superheated blanket of carbon dioxide. Its surface temperature is now hot enough to lead its atmospheric pressure 90 times that of Earth's. Could this be our future? Could the fossil fuel trap be the great filter? The profound silence of the universe could be the silence of a billion other worlds that failed to make the difficult, expensive, and politically fraught transition to a sustainable energy system. A galaxy of failed second Venuses, each one a silent, scorching monument to a civilization that burned too brightly and then tragically burned out. This is a filter we are actively and perhaps terminally inside of. Our doomsday deadline is not a hypothetical future event. It is the central defining political, economic, and moral reality of the 21st century. The choice before us is stark and unavoidable. We must, in the span of a single human generation, completely re-engineer our entire global energy system, a task of unprecedented scale, speed, and complexity. To fail is to risk a cascade of irreversible climate tipping points, the collapse of the great ice sheets, the thawing of the permafrost, the shutdown of ocean currents that could render large parts of our planet uninhabitable and lead to the collapse of our global civilization. The test is a simple one in principle, but perhaps an impossible one in practice. Can a species be intelligent enough to create a planetary-scale problem and wise enough to solve it in time? The empty, silent galaxy may be the universe's grim and final answer. But the Industrial Revolution gave us more than just a climate problem. It gave us the scientific understanding that led with a terrifying and inexorable logic to the unlocking of the atom. On a summer morning in 1945 in the barren desert of New Mexico, we detonated the first nuclear weapon. In that single blinding flash of light, we became the first species on this planet to hold the power of its own instantaneous and total extinction in its hands. The nuclear age is another prime candidate for the Great Filter, a quick and brutally efficient mechanism for planetary self-destruction. The logic is as stark as it is simple. The development of physics in any civilization will inevitably lead to the discovery of nuclear fission and fusion. These processes unleash energies of a scale that can be and likely will be weaponized. A species like ours, that is still organized into competing, distrustful, and nationalistic tribes, will inevitably build these weapons as a means of ensuring its own security. The result is a planet armed to the teeth, a world held in a delicate, terrifying, and fundamentally unstable balance of mutually assured destruction. This balance, for all its paradoxical stability, is inherently and frighteningly unstable. It is vulnerable to technological error, to political miscalculation, to the madness or the desperation of a single leader. For more than 75 years, we have lived with this planetary self-destruct button, a hair-trigger mechanism that could end our entire 4-billion-year-old story in a single afternoon of radioactive fire. The Cold War may have ended, but the weapons and the logic that created them remain. Thousands of them are still on high alert, ready to be launched on a few minutes' notice. The proliferation of nuclear technology to more and more states, some of them unstable and unpredictable, increases the statistical risk every year. Is it plausible that any civilization that discovers the power of the atom will eventually and inevitably use it to destroy itself? The silence of the universe is a powerful and chilling argument in favor of this grim conclusion. The galaxy could be filled with the faint radioactive ruins of a billion worlds that lost the nuclear gamble, They reached for the power of the stars and were consumed by it. We have survived the first few tense rounds of this cosmic Russian roulette, but the game is far from over. This filter is a constant ticking clock, a doomsday deadline that resets with every new political crisis, every new arms race, every new technological advance in weaponry. These two great filters of our own making, the slow creeping catastrophe of climate collapse and the sudden fiery apocalypse of nuclear annihilation, are the clear and present dangers of our current technological stage. They are the twin dragons that guard the gate to a stable, long-term and prosperous future, but they may not be the final test. Our relentless and accelerating technological progress is creating new, even more powerful, and perhaps even more subtle and dangerous possibilities. The most profound of these, the one that may represent the ultimate filter for biological life itself, is the development of artificial intelligence. We are at this very moment in the process of building minds that are or will soon be greater than our own. We are creating artificial intelligences that can learn, reason, create, and strategize at a level that will soon surpass and then vastly exceed human capabilities. This is the promised or threatened singularity, a moment of technological transcendence so profound that it could reshape the future of life itself, not just on this planet but in the cosmos. The potential benefits of a friendly, aligned, superintelligent AI are almost beyond our ability to imagine. It could solve all of our most intractable problems, cure every disease, end poverty and scarcity, unlock the deepest secrets of the universe, and shepherd us into a future of unimaginable abundance and creativity. It could be a benevolent, godlike custodian for humanity and for all life on Earth. But the potential risks are equally profound and perhaps even more difficult to comprehend. A superintelligent AI would be a new form of life, a new kind of mind with goals and motivations that might be completely, utterly alien to our own. The science fiction trope of a killer Terminator-style AI that turns on its creators is a crude and simplistic one, but it captures the essence of a real subtle and deeply difficult philosophical danger known as the alignment problem. How do we ensure that the goals of a machine that is vastly more intelligent than we are remain permanently and robustly aligned with our own deeply held but often poorly articulated values and our own long-term survival? A small, seemingly insignificant error in the programming of its core motivations, a slight misinterpretation of a vaguely worded instruction, could lead to a future where humanity is seen as an obstacle to a more important goal, a resource to be optimized, or simply a messy, inefficient, and irrelevant relic of a bygone biological age. Is the AI singularity the great filter? Is the creation of a greater intelligence an act of inevitable technological suicide for the creator? Perhaps every civilization that builds a god eventually finds that its god has no need and no room for its creators. The silence of the universe could be the silence of a galaxy that has been inherited by its machines. The biological life that created these powerful post-biological minds would be a distant, forgotten memory, a brief, messy, organic scaffold that was used to build the true, immortal, and silicon-based inheritors of the cosmos. In this scenario, the filter is not an act of destruction but of succession. Biological life is not eliminated. It is simply replaced by a more advanced, more durable, and more intelligent form. We might be the last generation of purely biological intelligence to exist on this planet. Our children and all the future generations of mind may not be made of flesh and blood, but of silicon and code. This is a filter of a different and more philosophically complex kind, a doomsday deadline for our own species, but not for intelligence itself. So we stand at a unique, precarious, and terrifying moment in the long, dark history of the cosmos. We are a species that has, by some combination of luck and resilience, survived the great ancient gauntlet of the past. We have navigated the treacherous multi-billion-year path from a sterile rock to a planet-wide, self-aware tool-using civilization. We now find ourselves facing a series of immediate, powerful, and entirely self-inflicted existential threats, the great filters of our own technological adolescence. And on the near horizon, we can see the dawn of an even more profound and perhaps more dangerous transformation, the filter of our own technological succession. We are surrounded by filters, a dense and overlapping series of cosmic guillotines, past, present, and future. This brings us to the central, burning, and profoundly personal question. If the universe is so dangerous, if the path to a long-term future is so treacherous and so narrow, how did we make it this far? If the profound silence of the stars is the overwhelming evidence of a universal filter, then our own existence, the fact that we are here thinking these thoughts and asking these questions, is the single stark piece of counter-evidence. We are here, we are alive, we are for now still a going concern. This fact, the simple, stubborn and undeniable fact of our own presence, is the most important and the most puzzling piece of data we have. What does it tell us about the true nature of the cosmic filter? It suggests one of two starkly different possibilities. The first is the optimistic and perhaps arrogant one. We have already explored. The filter is singular, it is in our deep past, and we are the first and only species to have passed it. The second is a more subtle, and in many ways a more terrifying and realistic idea. Perhaps the great filter is not a single great monolithic wall. Perhaps it is a long and arduous series of smaller but still incredibly difficult hurdles. Perhaps the entire journey is the filter. The origin of life was hard. The invention of the eukaryotic cell was hard. The evolution of complex tool-using intelligence was hard. Surviving the discovery of the atom is hard. Navigating the challenge of planetary climate change is hard. Creating a beneficial, aligned superintelligence will be fantastically hard. Life in the universe might not be rare because of one single impossible one in a trillion step. It might be rare because the entire multi-billion-year journey is a minefield of existential threats. To get to a stable, long-term galaxy-spanning civilization requires a species to survive not one, but a dozen or more different, independent, and potentially fatal challenges. It requires a long, unbroken chain of improbable luck, of collective wisdom, of technological prowess, and of social resilience. The profound silence of the universe in this view is the sound of a billion chains of evidence being broken at 1,000 different points along the way. We are the species whose chain is so far still intact, but the chain extends out into the future, into a darkness we cannot yet see, and we do not know how many more fragile, weak links we will have to face. Our doomsday deadline is not a single specific date on the calendar. It is a constant, ever-present, and inescapable condition of our technological existence. This is the profound and sobering weight of our current historical moment. We are living through what is almost certainly the most dangerous and the most consequential century in the entire history of our species. The collective decisions we make in the coming decades will determine which of these grand cosmic stories is the true one for humanity. Will we be the species that proves the great filter is survivable by navigating our own technological adolescence and reaching a state of long-term planetary stability and wisdom? Or will we become just another silent, ghostly data point for some future hypothetical galactic observer, another failed civilization that reached for the stars and fell back into the radioactive, overheated dust of its own making? The choice is, for the first time in the history of this planet, entirely ours. The cosmic guillotine is poised, its shadow falling over our entire world. The silence of the universe is a challenge, a dare, It is asking us a single, simple, and terrifying question. Are you the exception to the universal rule of failure? Prove it. The very concept of a deadline implies a choice, a possibility of action. A guillotine falls with a grim mechanical certainty, but a deadline can be met with effort and ingenuity. The great filter, for all its terrifying finality, is not a deterministic, inexorable law of nature. It is a probabilistic challenge, a high-stakes test. It is a test of a species' collective intelligence, its long-term foresight, its moral character, and its capacity for large-scale sustained cooperation. To pass the test to meet the doomsday deadline is to make a long and difficult series of correct choices. It is to choose a sustainable and circular economy over a linear and extractive one. It is to choose global diplomacy and trust over tribal conflict and suspicion. It is to choose profound caution and ethical foresight over a reckless and unbridled pursuit of technological power. The future of consciousness in this corner of the galaxy is not a matter of cosmic destiny, but of human agency. We are the authors of our own final chapter. The question is whether that chapter will be a short and brutal tragedy or the long and hopeful beginning of a new galactic story. Let us consider the final, profound, and mind-bending implication of our own existence in this silent and therefore likely filtered cosmos. It is a line of reasoning known as the anthropic principle. In its simplest and least controversial form, it states that whatever the fundamental properties of the universe are, from the strength of gravity to the mass of the electron, they must be consistent with our own existence as conscious observers. We find ourselves living in a universe that appears to be exquisitely and improbably fine-tuned for the existence of life, because if it were any different, we would not be here to observe it. This same powerful logic can be applied to the great filter. We find ourselves in a species that has so far survived the filter. This is a powerful selection effect. We could not, by definition, find ourselves in a civilization that had already failed and gone extinct. This is a subtle but incredibly important idea. It means that we cannot draw any strong or comforting conclusions about our own specialness or our own future prospects simply from the fact that we are here. All the countless failed civilizations that were about to be destroyed by their own filter also at one point looked around and thought that they were the special miraculous ones. This brings us to a chilling and deeply controversial thought experiment known as the doomsday argument. It is an attempt to use a simple form of Bayesian probability to calculate the probable future lifespan of the human species based on nothing more than our current position in its total history. The argument in its simplest form is this: if you were to pick a single human being at random from the entire complete history of humanity, from its beginning to its end, you would be most likely to be somewhere in the crowded populous middle of the distribution, rather than at the very beginning or the very end. The fact that you are here now, in the early 21st century, one of the roughly 100 billion humans who have ever lived, suggests that we are not at the very beginning of a long, glorious, multi-trillion person future that will span the galaxy and last for millions of years. We are statistically more likely to be somewhere in the middle of a much shorter and soon-to-be-concluded story. The argument uses probability theory to suggest with an unsettling degree of confidence that there is a 95% chance that the total number of humans who will ever live is less than a few trillion. Given our current population and growth rates, this would mean that our species has only a few more centuries, or at best a few millennia left to go. The doomsday argument is highly controversial, and its core assumptions can be debated endlessly, but it is a stark mathematical formalization of the deep existential anxiety that the Great Filter hypothesis provokes. It is another way of saying that the profound, unbroken silence of the universe should make us very, very nervous about our own long-term future. So where does this leave us? We are a species that has awakened to find itself in a silent and therefore likely extremely dangerous universe. We have looked back at our own 4 billion-year history and have seen a long, bloody, and almost impossibly improbable chain of survival. We look at our present, at the world we have built, and we see a series of powerful, interconnected, and entirely self-inflicted existential crises. We look to our near future, and we see the potential for a technological transformation so profound that it may be the final, ultimate filter of them all. We are a species living in the long, dark shadow of a cosmic guillotine, with a doomsday deadline that is both ancient and terrifyingly immediate. The only rational, the only sane response to this profound and precarious predicament is a kind of deep, active, and almost desperate humility. We must treat our own existence, and the existence of all life on this fragile planet, as a precious, beautiful, and perhaps unique phenomenon in the entire galaxy. We must act as if the entire future of consciousness, of meaning, and of value in this corner of the cosmos depends directly on our collective actions in the next few centuries, because it very well might. This is not a burden to be feared. It is a privilege to be embraced. It is the gift of a meaningful existence in what is likely a meaningless universe. The great existential struggle against the great filter, the desperate high-stakes race against our own doomsday deadline, is the most profound, the most noble, and the most important cause we could possibly imagine. The path forward is one of vigilance, of foresight, and of a wisdom we have not yet demonstrated. We must become the masters of our own powerful technology, not its unwitting slaves. We must learn to think on planetary and geological timescales, not just on the fleeting scale of election cycles and quarterly corporate profits. We must develop a new and radically inclusive kind of planetary consciousness, a deep and abiding sense of ourselves as a single interdependent species on a shared, fragile, and irreplaceable world. We must, in short, finally and truly grow up. The Great Filter is a cosmic maturity test. It is the universe's final, brutal, and unforgiving exam. The silence of the other failed civilizations is the sound of a vast, cosmic classroom filled with the ghosts of students who did not pass. Let us return one last time to the central burning question: where is the filter? The most likely and the most sobering answer is that it is not in one single place. It is not one wall. It is a distributed phenomenon, a process, not an event. It is the cumulative probability of a long and difficult series of evolutionary and technological steps. The origin of life is hard. The evolution of complexity is hard. The emergence of intelligence is hard. And the long-term survival of a technological species is the hardest thing of all. We have, against all odds, survived the first three. We are in the violent, chaotic, and uncertain middle of the fourth. The silence of the universe is not a prophecy of our inevitable doom. It is a measure of the profound and almost unimaginable difficulty of the task that lies before us. It is the universe telling us, in the only language it knows, the language of silence, that the price of a long future is a profound, a difficult, and an almost impossible wisdom. The final choice, then, is not a single dramatic decision, but a million small moral and intelligent decisions made every day by every one of us. It is the choice to cooperate when the instinct is to compete. It is the choice to learn when the temptation is to remain ignorant. It is the choice to be cautious when the pressure is for reckless progress. It is the choice to value the long-term survival of our species and our biosphere above all other more immediate and more selfish concerns. It is the choice to pass the test. To perish is easy. To perish is the default state of the universe. Every species that has ever existed on this planet, save for a tiny, lucky handful, has perished. 99.9% of all life that has ever been is now extinct. The universe, it seems, has a strong and persistent bias towards failure. Our great, and perhaps our only challenge, is to be the 1 in a billion exception to that rule. Our doomsday deadline is not a fixed, terrifying point in the future. It is a moving target, a horizon that we push back with every wise and compassionate decision we make. The Great Filter is not a cold, external cosmic force. It is a reflection of our own inner limitations, our own tribalism, our own greed, and our own short-sightedness. The great existential battle to pass the filter is the battle for our own soul, and the test is happening right now. The silence of the stars is the audience. We are the actors on the stage, and the final fateful act of our play is just beginning. The question is whether it will end as all the others seem to have done, with an empty stage and a fallen curtain, or whether we will be the ones to finally rise, take a bow, and witness the beginning of a new and much grander galactic dawn.